Welcome to the dynamic learning hub of XLR at Andheri East. Conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly We've also been recognized by Silicon India and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. In classroom session, you can still in the session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure to apply these concepts in their careers as well as their daily life.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the code and it was a great workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was...
I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concepts. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
very much interested in learning digital marketing course for a very long period of time. So, for course, I get to know XLR and I XLR course. It was really good experience. Our course is taken by my user and was very good teacher. He's not only focusing on paper, he's saying how real digital marketing works, and it was in total very good experience.
Good evening, all. Student, I request please from your institute session. Sir, good evening. Is my voice audible, sir?
Yes, yes, ma'am. Good evening, ma'am. Yeah, good evening.
Yeah, you can start the session, sir.
Okay, ma'am. Yeah. So let's start the session. And I'm sharing the screen. Please confirm. And we are going to start the session. Yeah.
Is
Okay. So good evening, all the students. Yeah. Thank you. So thank you for the confirmation. So today we are going to learn about supervised learning. So what is our goal? We have divided each day sessions we are going to divide. Already we have done into two parts. Okay. So theoretically we are looking theory, and we are going to implement whatever we are learning. Implementation. Okay. So for the theory, we are going to learn about today what is supervised learning, and in that supervised learning, what different types of the classification techniques are there, algorithms are there, and we are going to implement some algorithm, maybe two algorithm that we are going to cover, and we are going to implement those. Okay. So for this thing, we are using, I'm using Colab. You can use Google. Yeah, you can use Jupyter Notebook. Have already shown that how you are going to use Jupyter Notebook. Okay. So if you are locally working, so you have to install scikit-learn. Okay. So this library that we are going to use yesterday in the last session, that we have seen that how you have used sklearn. And today we are going to learn about supervised learning. Before going to this, let me show you that already you have my GitHub repository. So GitHub, and this is basically okay. This is complete repository that I'm putting day wise here. Okay, so EDA, I have all the files of the EDA day 10 and in day 11 supervised learning for the regression that yesterday we have completed. So for the today, you need these files. So we are going to implement these two, one decision tree and k nearest neighbor. These two types of the algorithm for today's session. Okay, so we will go some theory behind these two algorithms, and we are going to implement. And you need these two, that is CSV file, that are basically your data set. Okay, so you need KNN, this notebook, and decision tree, this notebook, and these two CSV files, and so you need to download all these. And yeah, again I'm going to share the link for this repository basically, and already you have the link. Okay, so you can go. So I'm sharing here the link in the chat, and meanwhile after some time again I will share when we are going to implement. Okay. So before that, let's have some theory about this supervised learning, that is classification. So let's understand, and I will make something that it will be easy to understand for the students. And so up to now, what we have seen that we have implemented the regression. So in that regression, basically what we did, and in the supervised learning, in supervised learning, what we did regression, and today we are going for the classification. Okay, so already I have shown you that how supervised learning data set, what type of the data set you have in supervised learning. Okay, so on the basis of the data set you are going to check whether you are going to perform a regression task or you are going to perform a classification task. Okay, so whether the data set, which type of the data set you have, and what is your problem statement, and which type of the task you are going to perform, that will depend on your target feature, target variable or target feature. Let me take an example here, that this type of the data, if you have this type of the data you have, this will be your first attribute, the first feature. This is your attribute 2, or the attribute 2, or the feature 2. So this is from here to here, these are my input features, and this is basically the class, either no or yes. We have two classes only. So this class is basically nothing but what, this is my target or the label. So the label or the class. Okay, so these data set, this will be your ID. So you may take ID as user input, okay, feature input, but we are not going to take. So from here to here, this is basically your input, and this is basically your output. If you go simple computer science programming, okay, so you have some input and you have some output. Okay, but in the machine learning we have both input and output, and we are going to give both input and output to the machine learning algorithm, and then that algorithm will try to find out the relationship between this input and output. Okay, so if we have labels like these, either 0 1 2 3, maybe this is 0 0 0 0, that is my no. Yes, that is 1 1 0 1. Okay, so you may have 0 0 0 1 2 3, this type of the labels, or you may have text categorical data. Okay, so already we have discussed that what are categorical data and what are the discrete. Okay, so if your target or your output is categorical, if this is your categorical, like this, yes no, male female, cat dog, this type of the data, if you have categorical, or this type of the data that is 0101 or the discrete. Okay, so you are going to perform your classification. Basically it will be a classification task when you have your output or your labels of the target variable as a categorical or the discrete values. Okay, so these data, see these data, this first data point belongs to no class. This data set belongs to this data point. This is data point, or generally we are going to say sample or the example. Okay, data point 1, data point 2, data point 3. So this is belonging to which class? No class. Okay, so some classes we have, and this type of the data we have, and we are going to we are going to train algorithm, and that learned algorithm will be your model. Okay, this is going to learn the model. Okay, what does mean learning the model? It This model, this algorithm is going to find some pattern between this input feature and output. Okay, so is there any pattern that how this whole thing belongs to this no class? Okay, this whole thing belongs to this no class. Okay, so it will take, there are different types of the algorithm, and there are different techniques to find out the relationship between input and output features. Okay, so it will try to find out pattern, and when that pattern is learned, that is your training phase. That is your training phase means, at the training phase the model is learning the pattern and the relationship between these two. Okay, when it is learned, your model will be there. Okay, so after learning the pattern from the data set, it's going to be your trained model. Okay, so this is your model is now done. The model has now capacity to predict for new data. Okay, so you are going to apply this model on some new data. Okay, so let's say this is test data or the new data, that these are not in our training data. Okay, so what is that? Now we have yes, no, yes, no, yes, no, all these things here, large and medium, large, medium, and this attribute is something in thousands. Okay, so this category, these two are the categorical features, and you are giving here this one that is numeric. Okay, numeric values. So using these things, what you are going to find, our model is learned, and now I am going to predict for the what will be the class of this. Okay, I am going to find out what will be the class of new data point. This data class, whether no or yes, which data class. This data point will belong to which, no or yes. Okay, so when your model is trained, the algorithm is trained on your data. The model is basically trained algorithm. So your model is trained, and now you are going to apply on the test data or any other data. Okay, that is let's say unknown data that is not in your data set. You are taking from the general. So this data will belong which class. Okay, so basically this is just the workflow you are going to do. So this type of the machine learning, if you have, so this will be basically, this will go, this will depend whether you are going to perform a classification or you are going to perform a regression. Okay, so earlier we have seen that what is regression. If your label or the target feature is, or the output, basically this is your output. Okay, in simple term, so this is continuous. So you are going to perform regression task, and if this is your output or your label or the target feature is basically discrete or the categorical that we have seen. Okay, so we are going to perform classification. Okay, so let's little bit understand that how classification will work. Okay, so we were trying. Okay, so let me do like this. Okay, yeah. So in the classification, we have seen in the classification, we are going to classify data points into some classes or the groups. Okay. So what we do basically, what we are going to do, that there are different algorithms. There are different algorithms are there. This algorithm is going to train on the data set. And when this is trained, you will get a classifier or the model. Okay, so this model is basically nothing but a classifier. So okay, so that model is a classifier, and now you are going to use this classifier to test for the new data points. Okay, so this is just, and whatever we are doing, this whole thing is your training. Okay, so how training is working, that we have to look into. And we have to go into the particular algorithm and how we have to see that which algorithm, there are different types of algorithms, and each algorithm has their unique way to learn patterns from the data. Okay, so we have to go one by one algorithm, and we have to understand if we are going to learn that algorithm or not. Okay, we are going to implement, if we are going to implement that algorithm, so we have to let me little bit, yeah. So what we are going to do basically, let's go with this. Okay, so what is this? Supervised machine learning classification falls under supervised machine learning because this has basically categories. Okay, the class is already defined that the particular data points will belong to which type of the classes. Okay, whether it is yes or no, whether it is dog, cat, whether it is diabetic or not diabetic, whether it is like any disease or not disease. Okay, different types of the classes you have for each data points. Okay, so predefined, the data classes are predefined, and you are going to categorize each element, each data points into predefined classes. Okay, so this type of the classification, this type of the task we are going to perform in the classification. Okay, so already we have seen that it involves to be label data. Label data means you have an output already, classes, labels are given, and you are going to find out relationship between input features and the classes. So let's say that we have two different features and our data points belongs to these two type of the classes, one this and other this. Okay, so we are going to find out, some separation line. Okay, the curve, we are going to find out some separation curve that can divide these two different types of the data points. Okay, so if we are going to find out this type of the curve, we can say that this curve is going to categorize the data points into two different types of the classes. Okay, so this is simple just representation, but how actually works, we have to go into a particular algorithm. Okay, so this type of this one, this will be called, this curve will be called a boundary. Okay, so this type of the boundary you are going to take, that will be your decision boundary. So reason one or the group one, this will belong to reason two. Okay, but you can see here these data points, this one plus belongs, go to the reason one, and this particular data point that is asterisk red in color, that belongs to that goes to this one, but belong to reason one. But decision boundary says that this will go to the reason one. So some errors we have, some classification errors we will have if each point is going to be classified by your decision boundary, then there will be a problem of that overfitting. Okay, so we don't need such classifier, we don't need such decision boundary that every data point is classified. Okay, there may be some classification error that is acceptable. Okay, you may have three different classes. Okay, so you may have this type of the boundaries. Okay, you may have this one, you may have this type of the linear boundary. Okay, so it's not that only a curve you have, but you may have straight lines, this type of the boundary. You may have only a single straight line, this type of the boundary. That is going to divide your data set into if your two class classification is there. Okay, binary classification basically. So these red data points are belonging to one class, let's say no, okay, or let's say diabetic persons, and this belongs to not diabetic person. Okay, so we are going to find out a straight line, a decision boundary that is maxi, that will basically what categorize into two classes. Okay, you may have this type of the boundary. Okay, like not a straight line, but this type of the boundary. Okay, so obviously if you have this straight line, so in comparison to this curve, this straight line will give you less accuracy. Okay, at the training time. But we are going to, let's say this one. Okay, this type of the boundary you are trying to find out. So focus, there is possibility of this type of, that is our model is very simple. Okay, lot of data points are misclassified. See here, these red points below the right side and below the straight line are misclassified, and these green points above and left side, the straight line are misclassified. Okay, you may have this type of the smooth curve. Okay, so this tries to find out more accurate classification of these two types of the data point, but still there are many data points that are misclassified. Okay, this boundary says that this green data points belong to this particular region or this particular group, but actually this is green that belongs to this. Okay, another type of the boundary you are going to put like this. So this will be very complex. This type of the algorithm or this type of the model will be very complex. This type of the algorithm or the model you are going to say is overfitting. Okay, because it's going to learn each data point, it's going to memorize each data point in your data set. But when you are going to generalize, when you are going for the test, you are going for the new data points, it will not be able to recognize correctly. Okay, so neither we need very complex data, neither we need very complex model. Okay, like this we don't need very complex like this model, and we also don't need very simple model that is many, that this model is going to misclassify many data points. Okay, so we are trying to find out a moderate type our decision boundary, a moderate type model that will maximize the classification. Okay, so maximum number of the data points will be classified, and we don't need this type. Okay, so we also don't need that every data point 100% data points are classified correctly. Okay, so we also don't need the training accuracy like 100%. If you are getting 100% accuracy in the training phase, so this means you are going to your model is going to overfit. Okay, and this will be the case. Your model is so simple that you are getting very less accuracy at the training, so this means you are going to have your model underfitting. Okay, so there is two types of the problem in machine learning classification when we are going to train our model for the machine learning classification task. Okay, so we have to deal with these type of the problems. Okay, so let's move to yeah, so this is my, let's say this is my data point, and we have to find out something like that. Okay, so either you are going the straight line, that is very simple, that is not going to learn most of the data points. Only 3 data points it has learned. Okay, here now very complex, that each of the data point it's going to learn. This is the symbolic. Okay, just to understand that how overfitting and how underfitting looks like. Okay, because when we are going to train our model. Okay, so these two different types of the problem you will face. Okay, and always in interview, always you are going to face these two types of the problems. So what? Let's say that this blue model is basically very complex, and it's going to memorize all the things. So we need a neither very simple or not very complex. Okay, but a moderate type our model, that is it, this green line. Okay, so this way you are getting moderate accuracy at the training and near about the accuracy while the testing. Okay. So see this thing, training time accuracy. If your model complexity is going high, your training accuracy will increase. Okay, but validation test or the testing accuracy when you are going to test. So what you will do, if your model is very complex, your test or the validation accuracy is going to decrease. Okay, we'll see all these things. What will be the training accuracy and what will be the test accuracy, and we'll try to find out these things. Okay, so that it will make clear to understand. Okay, so neither we need very simple that the training accuracy and the test accuracy both are very less, and we also don't need very high training accuracy but very less validation accuracy or the test accuracy. So we need that is the we need a moderate complexity of the model. Okay, so we'll try to understand these things in detail. So, okay, already we have seen this thing, that how a classification works. There are many examples of the classification that I said that we can classify, let's say, a diabetic person and not diabetic person, a diabetic, and whether a person has a tumor, so tumor is benign or the malignant. Okay, so we can classify. So for this classification, you have some classes, already predefined classes we have. So in medical, there are many use cases for the this thing. Okay, in image classification also, in medical image classification, whether that you are going to work on these things. So there is like whether you are going to classify this transactions, credit card transaction, whether it is legitimate or fraudulent. Okay, so you are going to classify between two classes. So there legitimate transaction or fraudulent transaction. So classification is there. So we have data set in this type of the transaction that already we have labels, we have classes that this particular transaction is legitimate, this particular transaction is fraudulent. Okay, So on in the data set, we are going to train our model, and for next time for the prediction when any transaction is happened, so we can classify that transaction on the basis of the previous transaction that our model has learned. Okay, so we can classify the transaction within that particular transaction is legitimate or fraudulent. Okay, so there are many classifications, many applications of the classification are in real world. Okay, so in medicine also, in here you can go for these things, and like structure, classifying secondary structure of protein as helix, alpha helix. So this alpha helix is one class, beta sheet is another class, or a random coil. Okay, so in you can divide, you can classify the protein structure in three different classes. Okay, there are different things. News stories you can classify in within whether either finance or whether or the different entertainment or these things. Okay, so there are different types of the classification techniques. Okay, so each classification techniques have will have their own way to train the model. Okay, so how the algorithm is learning from the data set. All the models will have different types of the algorithm, different types of the approach. Okay, so there are different techniques. Very important that most of the time this decision tree based, basically decision tree, random forest, and based on these there are many algorithms basis that based on the decision tree. So we'll look one algorithm in detail, that is decision tree. Neural networks also there. Neural networks can be used for the classification and regression, no issue. Decision tree also can be used for the regression, but most of the time we are going to use for the classification. Naive-based classification is there, support vector machines are there, k-nearest neighbors are there. There are different types of the classification algorithm techniques. So out of these, we are going to learn about decision tree and k-nearest neighbor today. Okay. So up to this, if anyone has any doubt, we can take, and we are going to learn about now k-nearest neighbor, and then we will implement k-nearest neighbor, and then move to the decision tree, and we will implement decision tree. Okay. So basically what let me something right here. Okay. So k nearest neighbor classifier. Okay. So this is basically what you have data points, you have data set. Yes. Anyone has any doubt? Okay, how to find a decision boundary for from the logistic regressions. Okay, so basically logistic regression you are going to use for the binary classification. Okay, so this is just implementation of the regression. Okay, so let's say let me explain this for the logistic regression first, and then we will move to the this classification. Okay. Sorry. Hmm. So we already learned about regressions. Okay. And this regression works how? We try to find out a straight line. Okay. Let's say that mx plus c, either we are going with that one, beta naught plus beta 1, that is x. This straight line will fall. Let's say my data set is something like that. We have seen one thing, one example. Okay, so let's say that my data set contains data points like this. Okay, you can plot a scatter plot, and you can check that which type of the data sets data points you have. Okay, like this. Okay, so you are going to find out a straight line. That will be your regression task. So what you are going to find out, you are going to find out a straight line here. Let's say this one. Okay, that one. Now what we are going to do? This prediction, this line will predict. This straight line will predict something straight. This straight line will predict some value. Okay. So those value we are going to convert into probability. So let's say this is going to predict. This is our predicted value, that is beta naught plus beta 1. For any data point you can check like this. For this data point, the predicted value, whatever the actual value and whatever the predicted value you are getting. Now we are going to convert this. Now we are going to pass this predicted value into your there is a soft max function. Okay, so this predicted value will be passed to your softmax function, and this predicted value will convert, basically it will convert into probability. Okay, now we have to find out the decision boundary, and we have to decide that decision boundary will be with how. Okay, this probability range will be in between 0 and 1. Okay, either you are getting the probability that is 0, or you are getting probability in between 0 and 1. Let's say that you are getting 0.4 probability, or you are getting 0.3 probability. Okay, so for a particular this. So this, if your data set predicted value and your that actual value are very near to each other. Okay, so you are getting the probability, you are going to get the probability around near to this one. Okay, so this will be something like that. Your okay, it will not be exactly 1 or not be exactly 0. Okay, you are going to find out in between 0 and 1, like this. Okay, now you are going to put some condition, you are going to put some like check that whether this probability is going to greater than 0.5 or something like that. So this will belong to that a particular class, let's say class 1. And if this probability is going to like less than 0.5, less than or equal to 0.5, so it is going to belong to category 2. Okay, so same regression task you have converted into the classification. So that's why this regression, this logistic regression, is basically we are converting regression task into the classification. So name is regression, but it's going to perform a classification for two classes. Okay, so keep in mind that this type of this for the particular this logistic regression is going to classify only two classes. Okay, your data point, if you have multi-class classification, like if you are going to classify into three classes, class 1, class 2, class 3, so you are not going to use this classification. Most of the time you are going to apply this. Okay, so let's move to the that k nearest neighbor that we have, k nearest neighbor. Okay, so in our data set, let's say that we have two classes. Okay, I will show that how two classes and three classes will work. Okay, so let's say that these two different types of the data points we have. Let's say this is another class. Okay, we have two different classes, two different data points we have. Now it says that this is your training. Okay, this is your actual data, or the data or training data. Okay, training data or actual data you have, like this. Okay, so what this is just the representation. You are not going to put like how you are going to represent this thing. Just to understand the representation, you can plot a scatter plot, and for the class 1, this first class you can give another color, and for the second class you can give another color. Okay, so what can you do? This, let's say we are talking about two classes. Okay, let's say diabetic and so this is, let's say this is diabetic class. Okay, and this is not diabetic. Okay, So now any new data point, any new patient came and the information about that patient, let's say fall here. Let's say fall somewhere here in between, here, somewhere here. Okay, this data point. Okay. So what it will be? Now we have to find out k nearest neighbor. Okay, nearest neighbors. So this k you have to think about what will be the value of the k, maybe 2, 3, 4, 5, 6 or okay. So this is basically one type of the hyperparameter. Okay. So let me just little bit explain about the parameter and hyperparameter. Most of the time students get confused with parameter and hyperparameter. Okay. So any unknown quantity, quantity in your machine learning model. Okay. So unknown value. Okay, like here in the linear regression, we have what? Y equal beta naught plus beta 1x. Okay. So these beta naught and beta 1 are going to learn in training. Okay. When your model is being trained, these values, these unknown values, unknown parameters or unknown what say you can say constants. Okay, these will be learned or these will be approximated while training. Okay, so any unknown quantity, any unknown variable or not variable, basically just the it unknown, what you can say, constants. Okay, are going to be learned in your training. Okay, so those will be your parameters. Okay, and this hyperparameter you are going to pass. Okay, these is also unknown, but decided by okay, trainer. Okay, trainer or the when are you, like you are training, so you are the trainer. Okay, means you are controlling the model, you are training the model. So you are going to supply or the machine learning engineer, you can say. Okay, so you are who is training the model. Okay, that those values of the hyperparameter will be provided by those trainers. Okay, so here k, how many k will be? These value of the k is basically decided by you and me, who is going to train. Okay, so let's say 8. This 8 value is decided by you. Okay, you may decide 8 or 10 or something like that. Okay, so there are different techniques to apply hyper techniques to like tune hyperparameter tuning. Okay, so how you are going to find out best value of the hyperparameter? You are going to check in hyperparameter tuning. Hyperparameter tuning. Okay, so we will see that how you are going to hyperparameter, you are going to tune your hyperparameter. Just tuning means you are going to find out best value of your this hyperparameter. Okay, so this is a known quantity and you are going to supply. Okay, let's say that it's 8. Okay, so what it will do, this algorithm says that you find the distance between, you find the distance. So let's say how I'm going to find out. Okay, let's say this is, so I'm going to find out distance between these two, distance between these two, and between all, okay, all pairs of the data. You are going to find out the distance between all pairs of the data. Okay, now what you will do, let's say after that you got the first distance, that is distance 1, distance 2, distance 3. You are going to arrange in what, in ascending or descending order. Basically you are going to arrange in descending order. Okay, so max yeah, ascending order, let's say. So that will be your the least distance. So let's say this is the least distance, this is the second least, this is the third least. Okay, so you are going to arrange in ascending order and you are going to take first 8 least distance. Okay, so you are going to select distance 1 to distance 8. Okay, and you are going to select these data points. Okay, so let's say that this data point, and this eight data points. You are going to select basically 8 data points, nearest 8 data points. Okay, I'm going to take this one. You are going to take this one. Okay, sorry, why this happening? Okay, so let's say that okay, just these 8 data points. You are going to take this one, this one. Sorry, again, it's not working properly. Okay, so you are going to take nearest 8 data points. Okay, so you calculated distance and you are going to arrange in ascending order with the distance. Okay, and now you are going to find out how many k is there. 8. Now you are going to find out 8 data points. Those are the nearest. 8 nearest data point you are going to find, and now you are going to check that the what is the categories, what are the categories of these data points. Okay, so let's say out of these 8 data points, 5 data points belongs to not diabetic. Okay, not diabetic, and 3 data points belong to diabetic. Okay, or any particular class. Let's say this not diabetic is 0 and this diabetic is 1. Okay, maybe class 1 and class 2, maybe class 0 and class 1. Okay, so this type of things you are going to find. So what you will do, you are going to say that you are going to find out the mode of these two. Okay, so don't confuse the mean, median, mode and all these things. Just you are going to find out the maximum data points belongs to which class. Okay, so out of 8 data points, those are the nearest of our new data points. How many, the maximum data points belong to each one. So these 5 data belongs to not diabetic. So this new data point that we have taken here, this new data point will belong to not diabetic. Okay, this will, so this will go to this class. Okay, this new data, this is basically what, new data. Okay, so this way, the simple algorithm, very simple algorithm. Okay, so let's move to understand with this one. So if you have only one neighbor, so what it will do, this is my new data point. Okay, so it will check that what is the nearest data point, that is only one. It will check the nearest data point. Okay, so this is basically this pink one related, this is going to this class, so it will go into this one. So this data, this x is basically is going to belong to this class. Okay, and if you are going for the two nearest neighbors, okay, so it will check for the two nearest neighbors. So there is a confusion, that if two nearest neighbor are there, then if that like you are getting same quality, two data points are here in our example we have taken. If let's say that 4 data points belong to one class and 4 data points belong to another class, then what, then which class it will go. Okay, so this type of the things you may face. Okay, so you are not going to decide on the basis of this one that which it will go. Okay, so if 3 is there, if 3 data points are there, so obviously you will get at least, okay, either 2 or 1 and like these things. So here, if you have k value as odd numbers, okay, so it will be easy to decide in which class the new data point is going to belong. Okay, so try to use new data like k value as that is odd points. So we have already seen that how it works. So you are going to initialize k value, and then you are going to calculate the distances, and then you are going to find an ordered collection. You are going to put into ascending orders. Okay, then you are going to pick 8 entries. Now here we have taken 8 entries, sorted collection. Okay, and now you are going to find out the labels of the each k entries, like 8 entries, and you are going to return the mean or the that is not the mean, it should be mode. Okay, for the regression, okay, yeah, for the regression you can use for the mean and for the classification. So this KNN and this is entry and different types of the algorithms are there. So they can be used for the classification and for the regression also. Okay, so we are going to use for the classification this k nearest neighbor. So you can use mode. Mode means that which class has the maximum data point. Okay, maximum frequency. So we are not going in detail too much. Okay, so let's implement so that we can, yeah, one point that you can use Euclidean distance. Okay, so just little bit, let's say that first data point is like 1 3, second data point is let's say 4 9. Okay, so you are going to find out the distance between these two. Okay, so how you are going to find the distance? Here we have taken the distances. So this distance, this distance. So this distance will be based on the Euclidean distance. Okay, and you can use, there are different types of the distance measures. Okay, but most of the time we are going to use Euclidean distance. Okay, so let's implement this algorithm. Okay, so let me show. Again, I'm sharing this repository link. Okay, so you can go and you can download the, okay, download the supervised classification, these things. Okay, files. Okay, decision tree KNN. So go for the KNN and iris and these things. These 4 files we are going to use today. Okay, so let's try to implement KNN. So you can go locally and you can go with Colab. Okay, so most of the time we have implemented in Colab, and now also we are going to implement in Colab. Okay, so open and go for the Colab, and okay, let me share the link of the, repository. Okay, so you go and download the files, dataset, and the Jupyter notebook files. Okay, so I have shared here. So what you will do, okay, go for the Colab and okay, go for the upload notebook, browse, and go for the wherever you have downloaded. Okay, so I have downloaded here decision tree and KNN. Okay, so I'm going to use KNN dot ipynb file. Okay, so it will, okay, so it will show you like this. Okay, all the things I have written, and I will show you how this works. Okay, so this is very easy algorithm. This is not going to take a lot of time. Okay, so let's understand. And what data type we are going to use? We are going to use basically Paima Indian diabetes. Okay, so what you will do, you download all these now. Okay, this iris CSV and iris, I think iris will be used for the decision tree classification, and Paima India's diabetes data. Okay, you download all these two data and data sets and these two. Okay, so now we need to upload our data at the Colab. Okay, so what we will do, just click here and you will go into the sample data. Okay, so in sample data you already have some files. Okay, CSV files. You can right click here, you can upload here, and you go where you have downloaded your data. So I have downloaded here my data, that is Paima India's diabetes data. Okay, so click on this, either double click or click and then open. Okay, so it says that after runtime is terminated, it will delete the data, whatever your file uploading. Okay, so no issue. Yeah, so we have uploaded. Here is my data, that is, so just go and copy the path. Okay, so what you will do, if you are working in Jupyter notebook, and your Jupyter notebook and your this CSV file is in same location. Okay, at same folder and same location, so just you give this, okay, this thing, either you have to pass the relevant the accurate path. Okay, so you have to pass the accurate path here. So here we have uploaded the data set, and here I copied the path of the data set like this, and then I passed here. Okay. So let's go to the classification, that what we need to do any data related reprocessing or data manipulation. You need pandas. We already have seen in EDA and the feature engineering part. Okay, and for any numeric calculation and for the numeric values, you are going to use NumPy. Okay, so these two things are very important, that you need to do these things. And here another library is there, that is sklearn or scikit-learn. Okay, you can go for the scikit-learn, and you have here what we are going to use, k neighbors classifiers. Okay, so you can check k neighbors kn. Okay, kn, so it will give you k neighbors classifier, and this will be basically sklearn your library. This k neighbors is basically a module within the library, and this k neighbors classifier is your uh, a class that is defined inside this neighbors module. Okay, so here different things you have. You are not going to give, this is the k value basically. Okay, neighbors, how many neighbors you need to calculate. Okay, on the basis of how many neighbors you are going to decide that the new data will belong to which data points. Okay, in which class. Okay, so this by default is 5, and all these things, when you are going to see that leaf size and other things, metric is Minkowski is used. You can change the metric as Euclidean. Okay, so all these things are there. You are going to use this k neighbor classifier. Okay, so how to import this particular k neighbor classifier class from the library? So you can use sklearn dot neighbors import k neighbors classifier. So you have to run this one. You run this, and you can see here this is connected, and this is okay. Fine, it is run. Now you are going to deal with your data. Okay, data set. So this is the way that we already have seen, that how you are going to load your CSV file into as a data frame. Okay, so this PD is nothing but pandas. Okay, pandas we have imported as PD. So PD pandas library is providing you read CSV to read. Okay, CSV files. Okay, and you can give here, you can go and you can check, just check the how my data set looks like. Okay, so if you go and you can find how your data set looks like, this is your CSV file. That is basically Pima Indians diabetes data set. Okay, so don't confuse with this Indian. This is basically a tribe in United States, Pima Indians. Okay, so they have collected a data about the diabetes. Okay, so this is a tribe in United States of America called Pima. Okay, so these are the things that you have to know, all these things. But here you can see that the column names are not given. Okay, so you can give here names of the columns from your like you can decide, you can define a list of the column names. Okay, and you can give, if you have downloaded your data set in which these columns are provided. Okay, so you need not to provide this particular parameter. Okay, so directly you can go up to like this only, and all the things will be there. Okay, then what we are going to do, we are going to convert our data into numpy arrays. Okay, so data frame dot values you will take, it will convert your data frame into numpy array, and we are going to take first eight you will check 1 2 3 4 5 6 7 8, first eight up to this, all these from A to H up to this, you will get our input features. Okay, and this particular 0R1 0R1 will be our what, our class or the label or the group. Okay, so this is my output, and from here to here, this is my input features. Okay, this is my input values, all the input values, and this is my output. Okay, so this particular data belongs to group 0, this particular data belongs to 1, this particular data belongs to 3. Okay, sorry, 1. Okay, so we have only 0 and 1, only two classes. So each data set will belong to either 0 or 1 class. Okay, So what we are going to take, we are going to take first 8 means we are going to take these values as input feature, and yesterday we have discussed that we are going to take input feature as x. So all the input features will be stored in x. So all these data will be from starting to the end. Okay, all these from these 8 from a to h will be in x. And the last one, that is our label. This label is going to be stored in this. Okay, so this is just find out how you are going. This will be for the all rows, this will be for the columns. So from 0 to 8 means the last one is not included, so this will 0 1 2 3 4 5 6 7. Okay, so up to 7 it will go, because the last one is not included. Okay, so this way you can do. And this is the last column that we have taken here as our output. So you can see here no issue. You can run this one and you can find this is 6 148, and these are the last okay, you can go with the data frame to check, but don't confuse with this. Just to find out input feature, what is my input feature? Okay, so my input feature is for 6 148 720 up to 50. So up to, from 6 up to 50, this is my input feature. From 1 to 31, it is my input feature. Okay, so you can find out a particular value, the first data point that is in input feature, like this. Okay, so 6 148 and all these values will be from 6 to 50. Okay, and labels. Okay, labels are the classes. So this y, this will be this is y, small y, which we are going to put into a small y variable. So this will be your classes. Okay, so you are going to print this y. Okay, so this first data point is belonging to 1, second data point is belonging to 0, third data point is belonging to 1. This is the simple. Okay, so up to this, what we have done, we have taken input feature in x variable and my output feature in y variable. Okay, so now I'm going to classify. Now I'm going to create a classifier that is our model. Okay, a machine learning model, that is my classification. That is what? K nearest neighbor. Okay, K neighbors classifier. So we have already imported this k neighbor classifier from the sklearn dots neighbors. Okay, so this is class. We have taken here model as a object of this class. Okay, so by default, if you're not providing how many neighbors you are going to take into account, so you can give 3 or 4 5, something like that. But if you're not passing this parameter, so it will by default take 5. Okay, now you are going to fit. Okay, so what it will do, it will learn all the data points, that which data point belongs to which particular label. Okay, just very simple. Up to this, what we have done, what we did, we just find our the input feature and output feature, and machine learning model building is this, generally this one. Okay, so just we define model, we are going to fit, and we have passed my input feature and my output variable. Okay, so you can run, and this is your training is done, your training is completed. Now you can predict. So for the prediction, you can use for any data point, let's say this one from here to here. Okay, so how many data points as input feature you need, basically? So 1 2 3 4 5 6 7 8. So for each column or for each input feature, you need at least one. Okay, so this here you need 8 input values. Okay, so 1 2 3 4 5 6 7 8. So this way you need to give all the feature values for the all input feature values to predict. So now you are giving this type of the data, and now you are going to predict this value, whether it is 0 or 1. Okay, so see here, you are going to take, this is new data, and you are going to take this one as model.predict. So for any machine learning model here in sklearn, you are going to use what that model is taken, you have taken, and there will be a fit. Okay, so whatever model that object is, that object will contain different inbuilt methods. Okay, so you can call. Okay, Now that you can fit, now you can use model.predict. Okay, so this will give you what? It will return a y, that will be the class or the label of the that data. Okay, so it's returning whether 1 or 2 or something depending on the data that you have passed. Okay, so let's run this one. So it says that this belongs to data 1. Okay, class 1. So this type of the things that you can do, and you can go for the accuracies. Okay, so here you can go for the accuracy. So this model dot accuracy you can go, that will give you simple accuracy. Okay, what is the accuracy of this model? That is 0.85. That means 85.93%. Okay, so up to this we have covered one machine learning classification model. So if you have any doubt in this implementation or this KNN, so please let me know. And if no doubt is there, so we are going to move to the next, that is decision tree. Okay, so okay, let's have a break of just 2-3 minutes, and I will be back. Okay, and we are going to start decision tree. Okay, so just 2 minutes break. Okay, so we are going to take a just 2-3 minutes break, and we are going to start. Okay, so what does accuracy mean okay, that's good question. So let's take this question and then try to find out what is the accuracy. Okay, so here, let's say that I have 100 data points. Okay, 100 data points. Here you can go in the Excel that how many data points we actually have. You can find like this. Okay, we have a lot of data points. Okay, and you can go with your this one. Okay, so okay, let's say leave this one and just try to understand. Let's say that we have 100 data points. Okay, so in that, whatever in data set you have, this particular things will be called as one data points. Okay, this is one data point, is another data point, means in Excel file and in CSV file, how many rows you have, that is data point. Okay, and let's say that when we are going to predict, when we are going to test our model. Okay, we trained our model, when we are going to test our model, so in that test we have 100 data points. Let's say for the testing purpose, we are going to predict 100 data points, the classes, whether it belongs to 0 or whether it belongs to 1. Okay, now what we are going to see, just if you have any doubt, put into the chat. Okay, I will take those. Okay, so this is for the testing purpose. Okay, and this data, these 100 data points are in our data set, and we already know that which data belongs to which class. Okay, so we already know that out of these 100 data points, which data point belongs to 0 and which data points belong to 1. Okay, so let's say in accuracy, means in reality, in actual, let's say that 60 data points belong to class 0 and 40 data points belongs to, let's say, how many, that 1. Okay, this is, now let's say that when you predicted for all these 100 data points, so how many data points belongs, let's say that it predicted that 55 data points belongs to class 0, and how many rest will be there, 45 data points belongs to category this one. Okay, so now you have to find out how many, what will be the accuracy. Okay, accuracy. So you can find out that total actually how many data points were belonging to the class 0. This was like how much? 60. But only 55, it says that only 55 class belongs to 0. Okay, but you have to think how many correctly classified. So let's say that uh, it's not. So we have to take into that how many correctly classified. Okay, correctly classified. Out of this 55, let's say that 50 belongs to 0, that is correctly classified, and 50 and 5 belongs to 1, means that is incorrect classification. Okay, and out of 45, it says that let's say 35 belongs to 1, that is correct classification, and rest 10 belongs to 0, so this will be incorrect classification. Hope up to this you have the you got the things. Okay, so this is testing. You classified, you predicted the class. Okay, you predicted the class for 100 data points, and you found that 55 predicted, this is predicted one, 0, and 45 belongs to 1. Okay, but in that predicted, you found that only 50 is correct classification and 5 is incorrect classification, because this 5 belongs to class 1, but it is classified as class 0. Now here you are going to find out what 45 classified as 1, and here only 35 belongs to, actually only 35 belongs to class 1, and rest 10 belongs to class 0, so these will be incorrect classification. Okay, so now you are going to find out how many correctly classified. Okay, so these 35 were actually belonging to the class 1, and they are predicted as class 1. These 50 were actually belonging to 0 and also classified as, okay, class 0. So now how many? 5, 85. So 85 correct classification. Okay, so this model, your model correctly classified 85 data points out of how much? 100. Okay, and this is incorrect classification, so 15 data points, this is incorrect classification by your model. These 15 data points classified to a particular data point, a particular class, but actually they were belonging to another. Okay, so how you are going to find out accuracy? Okay, so correct classification, you have to find out how many data points. Correct classification, that is 85, and actually how data points totally there were. Okay, so out of total how many correct classification were there, so you are going to find out, this will be your accuracy. So 85%, or you can say that 0.85. So this is the thing that this our model is returning. Basically this, whatever, 85.9. So you will get 85.9% classification. Okay, accuracy. So I hope whoever asked the question, he got some insight. Okay, so sorry, my this was off. Okay, let me take just 2 minutes break, and we are going to have, okay, please give me 2 minutes. Okay, and I will be So welcome back. We have another question. That is which formula is used for the distance. Okay, for the distance. So whatever we have used here, that is Minkowski. That is, let me check that with default one is in that. Okay, so here the default is Minkowski. Okay, so there are different types of the like distance metric. Okay, so Euclidean distance or the Manhattan distance or Minkowski distance you can use. So here by default Minkowski is your matrix. Okay, so this metric is nothing but your distance to calculate the data point distance between two data points. Okay, so this is Minkowski. And if you want the formula, so it will be something like that. Let's say that this is your data point 1 2 and this is your data point, another data point 5 6. Okay, so what you are going to say, not only this one, actually data point, let me explain something like that. Your data point, what data point is, this whole thing is your data point 1 185 and this, and with comma you are going to put your data point. So let me copy from this. Okay, from somewhere. Will it work or not? Okay, no, it's not working here. So okay, I'll leave this one. So all these things means 1 comma 185, you will find comma 60 comma 23 comma this and this and then up to 8 data points you will have. Okay, up to 8 you will have data points like this 160 184 something like that, up to 8. This one, this is your data point A, and data point B, let's say this data point 0118 something like that, this is another data point. Okay, so what you are going to do, you are going to subtract first part from the first part, 1 minus 0, then you are going to put any power when you are using Minkowski. Then you are going to put 60 minus 118. Then you are going to put the power. Let's say power is basically nothing, 2 3 4 5 1 2, any power it may be. Okay, so you have to decide. So by default it will take what power as 2. So when power is 2 and it is like metric is Minkowski, so it will give you your Euclidean distance. Okay, so it will be something like that, and you do for all data points, for all parts of the, or for all features. Okay, subtract and square, then you take under root. Okay, so this will be your distance between this A and B. Okay, so by default this is when Minkowski, the power is here, power is 2, so it will be Euclidean distance. We have learned these many times. Okay, in your school days you have learned this one. Okay, so let's move to the decision tree, and quickly we are going to implement also this decision tree. So let me show you the main, that how it works. Okay, so in decision tree how it works basically. Okay, so we have data set. Let's say our data set is like that: categorical data, and continuous data. Okay, yes, no, single married, or diverse. Okay, and taxable income, something like this. Whether taxable income is what 25,000, and whether it belongs to yes, no. Okay, in which class it belongs. Okay, so this type of the data you have. Now, decision tree algorithm is going to find a tree-like structure. Okay, a tree-like structure on the basis of your these features. Okay, so it will find out the best feature. There are different ways to find out the best feature. Okay, you can use Gini coefficient, or different techniques are there to find out best feature. Okay, and information gain is there. Okay, so you can use the technique, and inside I will show that how you are going to decide which technique you are going to take. So let's say that this refund is basically what, on the basis of refund you are going to divide your whole data set into two parts. Okay, one part will be for the this one refund is yes, and other part that is refund is no. Okay, so if refund is yes, you can find, so belonging to the class, if refund is yes, class is no. Refund is yes, class is no. Refund is yes, class is no. So for all refunds where yes is there, so your final class is no. Now you are going to say if your refund is no, then you are going to say that whether you are going to check another feature, okay? Because directly you can't say that if refund is no, then in which class is it's going to belong, okay? So again, you have to go and check for the best feature to split your whole data, okay? So you are going to split your data into different part, that whether it is married or single, okay? So if it is married, then you are going to say, you can check married then no, married then no, married then no, married then no, okay? So this way you are going to split your data, and you will find that you will find a decision tree like structure, okay? And each node here, each feature will be treated as node, okay? And final node will have basically your class, okay? What is in which class the particular data point belongs, okay? So whether it belongs to no, so you can find here at the end leaf node will be your value for the your label, okay? Whether yes, no, yes, no. So this type of the structure, it will train a machine learning model for the decision tree algorithm, will train on the data set, and then any new data point. So one thing is that not only one single decision tree you will find, you may find different, you can find different structure, okay? But final tree structure will be decided that which your machine learn, yeah, this one, which feature is the best feature. First you are going to take as a root, then we are going to take the middle nodes and final your leaf node will be, okay? So there are not just one tree like structure from your one data set you are going to find out, you are going to find out different tree like structures, okay? So let's say this is my best tree structure that decision tree has learned, okay? So this pattern, or this, we can say whatever the tree structure learned, this decision tree algorithm on this data set, okay? So now you are going to use this tree structure to predict for the new data, okay? So we have seen here that tree algorithm will be there, your data set will be there, and your model will going to learn the structure, okay? Structure or the pattern, and there your model is learned. Now you are going to apply, and now you can predict that this particular data, no small 55K, will belong whether no class or yes class, okay? So let's say that you got a new data, that is this new data, you are going to decide, you are going to predict with the learned data, learned tree structure, okay? This is your model basically, that your model learned this structure, okay? Now you are going to say that you are going to check refund, okay? So refund is no, okay? If refund is yes, so directly you can say that your cheat class will be what? No. Now refund is no, then what you have to do, you have to go in this branch, okay? No branch. If your refund is yes, then you can go directly in this branch, and finally you can predict that your this data belongs to no class. So now the refund is no, you have to go in this branch. Now you are here, you are this subtree, okay? Now you are going to check whether marital status, what is marital status, is married or what? So you are going to check that it is married, okay? So what it will be, your marital status you are checking, so it is married. So now you are going to say that finally what, this data set, this data point will belong to class directly, okay? So you need not to check that whether income, taxable income is what, okay? You are not going to check. So directly you can say if marital status is married, so you are going to say it as no. So you are going to assign this data point as no, means your model, this is basically what? This is your model. Model has learned this tree structure, and on the basis of this tree structure, you are going to predict this data point, that is no, married, and TK is going to belong with class no, that is T class no. Okay, so I hope this is little bit good, that you are going to understand. Okay, okay, attendance you are getting. So let's move ahead and go with our Let me check that what different things we can do more. Okay, so just let me introduce one more thing that is very important that we are going to check. Okay, how you are going to identify here? Here we have decided that this refund is my root node. Okay, so whatever the refund, whatever the root node is, that is your most important root. So in the decision tree, the most important thing is how you are going to decide your root node and how you are going to decide the best feature. Okay, or the most important feature. So, and then you have decided the first root node. You divided your whole data set into two different parts. Okay. Now again you are going to both branches, and from both branches you are going to select the best feature. Okay. So this thing you have to do. So let's say that here the serial number is there, ball size is there, ball color, to just understand. Okay, price is there, and so in simple way, you are going to say that one my feature, let's say ball size is feature, ball color is feature, price is feature. Okay, and whether you are going to play or not. Okay, useful or not for play. So this will be what? This will be your label or the class. Okay, this is your class, and these things are your input features. Okay, so out of these three, ball size, ball color, or the price. Okay, out of these three features, which one is the best or the like good feature? Okay, so in simple term, any feature which has more variations, okay, more variability or more varieties. Okay, so here you can find out ball color only red, red, red. Okay, so this red, 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 all balls are red colored. So we are not going to decide. We are not be able to decide on the basis of color whether you are going to play. It is useful for the play or not. Okay, so in any feature that has variety of the values in that. Okay, so here 1 5 10, only different only three different numbers you have, three different values you have. Here only one different values you have, ball size 1 10 50 1 2 3 4 5. Here five different values you have in ball size. Okay, so this will be your five. This ball size will be your best feature, good feature to like what, to split your data. Okay, so to make your root node. Okay, ball size will be your, it will be your root node. Okay, okay, so at first the best feature is ball size. Okay, now you divided your whole data set into two. Okay, now you have to decide whether greater than 50, okay, will come into another category, and less than 50 will go to another category. So, okay, again on the basis of this thing you have to decide whether ball color or the price will be the best feature. Okay, so in this way you have to go, you have to keep dividing your whole data set, and at the end you will reach at your root node, whether yes or no, whether yes or no. Okay, so there are different techniques, there are different techniques to find out the best feature. Okay, but if you can go with this technique, just it is just like by looking or by seeing these things you can find out that how variety your feature has. Okay, but in reality you have millions of the data points. Okay, so you can't not decide by looking. Okay, so you have to go with the concrete techniques. Okay, so one is our what, one technique is that you can apply basically this entropy feature. Okay, so we look into when we are going to this is typically entropy is measured. So wherever the variety is there. Okay, so like variance of the data is too much for a particular, here you have seen here you have seen ball size, there the variety is like 5, here is the variety is only 1, here the variety is 3. So that feature having the more variety or the more variance will give you the information gain on entropy, maximum entropy. Okay, so another way to compute the best feature, to find out the best feature, is to compute the entropy, and this will be the formula. And in different, and let's say that you are going for the decision tree. Okay, so let's check decision tree classifier, and I'm going to show you that for different types of the hyperparameter you are going to check. So this will be decision tree classifier, and within decision tree classifier you will find what the criteria is. So this is basically nothing but what, this, whether you are going to use entropy or you are going to use their Gini coefficient is there. Okay, so there are different techniques to find out information gain. Okay, so this will be the criteria that Gini or the entropy or whatever the tech criterion you are going to use to find out which feature is the best feature. Okay, so on the basis of information gain, you are going to say that this particular feature will be the best feature. If information gain is maximum, so you are going to say that feature is the best feature. Okay, so here the splitter different these, whatever the parameters you are passing here, these parameters will be called as hyperparameters. Okay, and you have to decide whether you are going to take Gini coefficient or you are going to take the entropy or whatever criteria you are going to choose. Okay, so it will depend on you. And minimum sample, okay, how many minimum sample is there left in our data set when you are going to split. Okay, so there are different things that you can control the structure of your tree. Okay, so there are different parameters that you have to pass to control the structure. Okay, so there are different things, all these things will be your hyperparameters. So three things are very important. One is the criteria. On the basis of this criteria, you are going to decide which feature will be the best feature. Okay, max depth that you can check here, that what will be the max depth. Okay, so here the depth is 1 at this level, depth is 1 at this level, depth is 2. Okay, and this level depth is 3. Okay, but in real life data you have millions of the record, and not only 3 or 4 features, you may have 100 features. Okay, 100 of the features. So what you will do, you will get like many you can go up to many levels. Okay, not only 3 4, you can go up to 50 60 levels. Okay, but now you have to decide that how many what will be the depth level you want to go. Okay, so if you are not going any depth level, okay, so it will go up to the end, it will go up to the root node. Okay, if you are going to put here like say like 10, okay, so it will go up to the 10th level. Okay, and there it will stop. Okay, and further it will not go up to the leaf node. Okay, minimum sample. Okay, so minimum sample you can find here, like here you decided, you divided, and you are getting in this this subset that all have how much, let's say here, so no is 1 2 3 4 5 6 6 6 will fall under this, 6 data set fall under this, and others 1 2 3 3 will fall, 3 or 4 will fall under this. Sorry, no was here. Okay, so no was here, so 6 or 7 will fall under this. Okay, and only 1 2 3 will fall under S. Okay, so you can decide this, how many minimum samples you need in a particular subset of your data set to further divide. Okay, so let's say that you said that I want to put 3. Okay, so this particular subset has 3, only 3. Okay, so now yeah, so now you are going to again divide, but if we the subset, the value, how many values are there, data points, let's say only 2 data points belongs to this particular subclass, so it's not going to divide because it is less than this. Okay, so you can put different conditions and different things. So these two things are the very important, that are the things that you have to look into. And yeah, so almost we have covered all the things for the theoretical things. Let's just quickly go and implement this one. and you will find that how it will look. So already I have shared this one. Just download decision tree and the data set. Okay, so we are going to just import this one, and I will show you how you can do. So you can go for the collab for the new one, and you just import, you upload your downloaded Jupyter file. Okay, so what you will do, just go to the file, just upload notebook, and in upload notebook, just you go for the browse. Okay, then click on this decision tree. You have wherever you have downloaded, you have to go there and just upload this. On Colab, you are working in Jupyter Notebook, then that's fine. You have to install all these libraries, sklearn, NumPy, Matplotlib, Pandas, other things. Okay. Now for this thing, we are going to use iris data. Okay. So for this, you have just upload the iris data here on the Colab. Okay. So what you will do, just click on this and you will find here that this is already connected, and now in the sample already we have seen that some default data set is available. You can go to upload and just go for the iris data set. Okay, again you will get warning, so no worry. After termination, when your runtime will end, the data whatever you have uploaded will be this data only. This your file will remain. Okay, no, so this your decision tree IPMNB file will be remaining there after runtime is disconnected, but your data here, whatever you have uploaded, will be deleted or removed. So where is my data? Iris. So go and right click and just copy the path, and I'm going to put here. Okay. And if you're already working in the local, so you can just go by default path wherever you have. So these things, and what different things we need? We need this decision tree classifier. Okay, so this decision tree classifier you can find. sklearn is what? Your library. This tree is what? Your module. A module within this library, and from this module you are going to find out this decision tree classifier. Okay, so this is important. Before that, train test split. If you want to split your whole data into training and test data set, two different, okay, part, one for the training, another for the testing. Okay, so first time you are going to do this one, you will check that this how it will work. Okay, and the matrices, classification matrices you can do, and pre-processing if you need. Okay, so let's run this one. Always, all the time, you need not all these things that we have imported. Okay, so you need this classification, decision tree classification classifier, and we already have this. Now I'm going to convert my iris data that is in CSV file into this pandas data frame. Okay, so this iris variable will be a pandas series, pandas data frame. See here, data frame, that is iris, and you can find different things here. So what it says that, it says that what is the shape of this? You can find the shape is 150 rows and 5 columns. Okay, you can find the head, and you can find directly. You can print basically iris dot shape. Okay, so you can print also that how many data points you have. So 150 data points means our CSV file contains 150 rows and 5 columns. Okay. And what we are going to do? We are going to convert these things into which one? These things. Okay, iris and these things. So when we done EDA and data pre-processing, EDA data pre-processing and feature engineering. So one thing we have discussed that if if you have any feature as a categorical feature, so what can you do? You can convert that categorical feature into some numeric value or into the discrete value. Okay, so there are different techniques that you can use. One is like level encoder, other is something like directly you are going to give whatever other things, dummy variables you can create. Okay, so these things you can do. Here we are going to use label encoder. Okay, so what label encoder will do, it will give you numeric values for these things. Okay, So pre-processing level encoder, and from this species, basically these species, it will try to find out how many iris setosa is there, iris setosa is there, what different types of the species are there, and on the basis of those values, it will try to find out the labels for particular species. Okay, so this will belong 0, and this. Okay, so all the things you can find out data after what. So what will be your x and what will be your y. So here you can find out, what this is, your x, and this is your y. X is what, from here to here. Okay, so these 3 points, these 3 things will be taken into your input features. That is, we are going to take input feature as x, and not 3, sorry, this up to this one, up to this. Okay, so all 4 input features, they will be treated as input feature. This one will be treated as your output, or the classes, or the labels, or the target. Okay, variables. So in input feature, we are going to take all these 4, and for the y, we are going to take this. Okay, so you'll find here, and x is your input feature. You are going to take these 4 points, and for the y, you are going to take these. Okay, so this is basically nothing but earlier how we have, that iris dosa and all these things. Now we have what, 0, 0.2, 0.4, 0.6, something like that, up to 2. Okay, so we have these type of the values converted by level encoder. Okay, so you can find how many. Okay, so let me check that one important thing. Okay, let me check that one important thing. Species that is 0 1. Okay, species. Okay, so sorry, so basically that how it is going to done. So what it will take, let me make it clear, either it will confuse you people. Okay, so we have seen here that in the space, this one species, in this species, how many different species we have. Okay, so how many species we have? Basically, we have 3 types of these species. You can go into the excel file and you can check uh, these things. Okay, and okay, so either iris etosa, or this iris versicolor, or the iris virginia. These 3 types of the classes we have. Okay, so what it will do, basically, what our label encoder will do, label encoder will give the labels, like for the first class 0, for the second class 1, 1, and for the second, or for the third, sorry, for the third, it will give you 2. Okay, so for the first class, that may be your this one. Okay, that may be arisitosa, and for the second one, it will give 1, and for the third one, it will give 2. Okay, so it will give basically labels 0, starting from 0 1 2, like this. Okay, so these are now x and y we have, and in that these things we have labels, that will be labels 0 1 and 2, and iris species, that value count you can find. So in species 0, like in species that belongs to class, how many data points belong to species 0, that is class 0, and how many data points belong to class 1, or how many data points belong to class 2. Okay, so all are like 150 we have, so 50 data points belong to each 3 categories. Okay, so now you can find here what different columns are there. Okay, so we are not going to into this. Okay, so train test split, basically what train test split will do, 150 data points we have, we are going to take test size as 2%. Okay, so 150 out of 150, 2% it will reserve for your test. So 30 data points it will reserve for the test, and rest 120 data points for the training. Okay, so it will take 120 data points for the training, and 30 it will reserve 30 data points for the test. Okay, so in future when you train the data set, now you can test with these 30 data points. Okay, hope this is clear. So it will give you train test. Okay, so it will give you X level of the train, X level of the test, Y level of the train, and Y level of the train. For the this X will be what? The input feature for the training data. This will be the input feature for the test data. This Y train will be like output features are the classes for the training data, and this will be output features are the target feature for the test data. Okay, so run this one and you can find X train. Okay, so this X train will contain how much? 130 data points, and this Y train will contain, oh sorry, X train will contain 120. You find here 120 data points, and your okay, your Y, this Y train will contain your how many? 120, uh, 120 features on, not sorry, 120 points, data points, but for the that Y levels. Okay, that will be your classes, whether it belongs to 0 class or 1 class or 2 class. Okay, like this. So this is done. I think yeah, 14 we have done. Now just go, and another thing that you can find out here, what will be the Y train for the Y. You can find it. Okay, so it will give you like 10012 something like that. Okay, so it will give you all the classes. Okay, whether it belongs to 0 class, whether it belongs to 1 class 1 or class 2. Okay, so size of this thing you can find out 120. Okay, and for this test, for the test it will give you 30, the remaining 30 for the test. So input feature for the test, and it will be your target feature or the target variable for the test. Okay, now we have defined X train and Y train, and we have already imported the season tree classifier. Now you can provide what type of the criteria you are going to put here. Okay, so criteria by default is Guinea. If instead of Guinea you are going to put any other criteria to check that which one is best feature, so you have to provide. Okay, so instead of the default features, default parameters, any other value you are going to provide, so you have to pass that one. Okay, sorry, where it is? Oh, this one. So for the criteria, let's say I'm going to use for the entropy and the max depth. So max depth is not given here. If you are going to provide max depth, what is 3, 4, 5 and whatever, so you are going to you have to pass any parameter. Okay, if it is not passed, so what you have to do, it will go up to the end of the node. Okay, and just you are going to do what? Train just the X, that is input feature for the training, and this Y, that is what? Y train is basically what? Your labels for the training data set. So you run this and you will train. Okay, now you can find one more important thing, that this tree module contains plot underscore tree. Okay, so it will plot the tree that we have already seen. Okay, so in that first, what it will take, it will take sample that is less than 2.45. So x2 is what? And entropy, it takes entropy is this, sample is 120, and value is this thing 42, 30, and this one. This is true if this is less than 2.4, it is true. If not, then it will go like this. Okay, let me check. Okay, so this is, I think this tree is better representation, so you go with this tree and proper way. Okay, so what it will check, it will check the petal length in centimeter that we have seen. Okay, if petal length is less than or equal to 2.45, so you are going to, if it is true, then you are going to divide another subset. Okay, if false, then you are going to divide into So you are going to divide your whole data set into two subset on the basis of this petal length, whether your petal length is what, 2.45 or less than that. Okay. Now, on the basis of petal length, it is done. Now you are going to check whether petal length is less than 1.75 or not. Okay. So you will get this. Now this way you are going to divide your whole. Okay. So we have given how many, that one, 3, max depth is 3. Okay. So yeah, so it will go up to 3. This is first level, this is second level, and this is your third level. Okay, so finally final is 3. If let's say that it was not given, okay, so it may, if 3 was not given, so it may further divide your data set into different parts. Okay, so now you can find here these things. If before reaching the maximum, before reaching the max length, let's say that you reached at the final root, okay, leaf node, okay, so it will stop. Okay, let's say that we have given maximum length is 3, and only with these two, first and second, only these two levels, is max length of the two, you reached at the leaf node. Okay, so it will stop at 2, it will not go to up to 3. Okay, that is the one thing. So let's predict that thing, the series that you have taken this test data and you are going to predict the test data. So let me print this one before that. Okay, so what you can do, you can print your, complete this one. Okay, this is already printed, so no issue. So what it says, we have done, we have predicted. So this spreads, this will take what, this will take either 0, 2 or 1. 0, 1, 2, 0, 1, 2 means this whole test data belongs to which class? Okay, 0 class or 1 class or 2 class. Okay, so we are going to say, and you can find out how many data points. So for the class 1 there are 13 data points, for the class 2 there are 9 data points, and for class 0 there are 8 data points out of 30. So we reserve 30 data points for the test data, and we have 1, 2, 3, 1 to 0, 1 to 0. These are the class levels. Okay, so it will start with the descending order, like this class 1 belongs to, this class 1 has 13 data points, that is maximum. Class 2 has 9 data points, class 0 has 8 data points. So you can check here, like class 1 appears 13 times, maximum time 1 appears. So 13 data points belong to class 1, 9 data points belong to class 2, and like these things you can find. Okay, so one thing you can do here, cross tab also. Cross tab is very important. This is a good feature in your like EDA, and when you are going to perform exploratory data analysis, you can do the cross tab. Okay, so this particular things that class 0, and particular thing that you can find out how many things are there. Okay, so this will give you a little bit information that whether correct classification was not. Okay, so how many 0 and 0? So 0 belongs 8 species, 8 data points predicted as 0, and actually they were belonging to 0. 12 data points were predicted to 1, and they were belonging to 1. Okay, and here you find 9 data points were belonging to 2, and they were predicted to 2. But here you can find out 1 data point is predicted as 2, it is predicted as basically 1, and actually it was belonging to 2. Okay, so that is in this one you will get 13. Okay, so it predicted 13 data points to belong to the class 1, but one you will get like one like incorrect accuracies, incorrect classification. Okay, so on the basis of this, out of 30 only incorrect classification was there. So you will find out what, you will find out mean. Okay, you will find out the accuracy. How will get accuracy? Like 29 correct classification divided by 30 out of 30. So you'll get 96, almost around 96. Okay, directly you can go like this model dot score, for you can give your x text and y text. Okay, so you will get find this thing. Using Gini criteria, you can find just you go and just put your criteria as Gini and run all these things. You will get the accuracy. What is the accuracy is 0.96 something. So almost you will get these things similar. You may get for the classification this decision tree you may use for the regression also. So you can use this thing. So which data set? Okay, iris data set we have used. So for the classification, you can take decision tree classifier for the classification, and for the regression, you can use decision tree regressor. So this will be your X and Y, and you can train test split, you can fit the model, and now you can find the score for the classifier. Okay. So you can do further. This one will be regressor. Okay, so you can use this KNN also. You can use this decision tree, and you can use different models are there based on this decision tree. Okay, like random forest is there, different gradient boosting methods are there. Okay, so you can use those things, XGBoost and different gradient boosting algorithms are there. You can use those for the regression and classification both. Okay. So up to this, we have completed our implementation. So if you have any doubt, please let me know. And yeah, you can go to the repository, you can download all the files, data set, and this, and you can run locally, or you can run your this Jupyter notebook on Git, this Colab. Okay. So if you have anyone have any doubt, so please let me know, and we can conclude here either. Okay, so any of you. So what we have done. We have completed our classification. Okay, there are different techniques. There are many other classification models are there. There are many models are there. Like SVM is there, another good example of the classification model. Okay, and there are many more. Naive base is there. Okay, so there are many sklearn.svm you can find. Okay, so there are different SVM. Yeah, there are different classification. You can go sklearn classification models. Okay, you can check there are many models you can find in supervised. All will fall in supervised. Okay, so these linear models you can check, and support vector machine used for the classification and regression, a gradient descent used for classification and regression, neighbor and nearest neighbors classifier, nearest neighbor regressor. Okay, so you can find nearest neighbor classification, nearest neighbor classifier. Okay, Gaussian is different thing. Naive Bayes classifier, Naive Bayes. Okay, you'll get different decision tree classification, decision tree regression. So you'll get lot of many decision many models for the this classification and regression. Okay. So ensemble methods are there, ensemble algorithms are there, gradient, random forest, and all these. Okay. So these random forest methods are based on the decision trees. Okay. So a lot of many algorithms you will find. Okay. But we are not able to cover neural networks also. Neural networks will be used for the classification, for the regression. Okay. So you can go for the deep learning. Either you can check for the different algorithms, different neural networks already done for the classification, for image classification, for the text classification, for the numeric classification. There are different algorithms in neural network. Okay, so these things also can be used for the classification and regression. So you can explore furthermore. So let's do tomorrow some new thing, maybe hyperparameter tuning, and how you are going to improve accuracy of your model in machine learning. Okay, so how you are going to make hyperparameter tuning. So today we have seen that what will be the hyperparameter and what will be the parameters. Okay, what are the differences between these two? So you can use different values of the hyperparameters to find your optimized the model accuracy or model metrics. Okay, so let's do tomorrow and let's deep dive into like how you are going to increase your model accuracy and how you are going to work on the hyperparameter. So okay, I hope there is no question and there is no doubt, so we can conclude our session here today and let's meet tomorrow. If any doubt, again I'm saying that we can discuss just for 5 minutes. If no, so we can conclude the session here. So I hope there is no doubt. Okay. So Sushmita ma'am, we can conclude the session.
Yeah, sure, sir.
Disconnected. Okay. Layout. Content only. Yeah, that's good. Okay.
Okay, so thank you. We will meet again by tomorrow at 7 p.m. So thank you so much.
Okay. Yeah, that's good. Yeah.
Yeah,
Okay.
so
Good night, ma'am. Good
yeah, good
night.
night, sir.
Good
Thank
night,
you.
all the students.
Yeah, thank you all. Thank you for joining. Good night, everyone.